As we prepare for polynomial functions and power functions, what you're going to see is that a lot of the things we need doesn't require a lot of work. It's knowing that certain characteristics will determine the behavior of the graphs of these functions. Now first there's the degree of a term of a polynomial function. Let's say the term is a x to the n, that the degree of that individual term is n. It's the exponent for the variable. The coefficient of the term a x to the n is a. It's the number that's multiplying the variable being raised to that power. Now the leading coefficient of a polynomial function is the coefficient of the term with the highest degree. So let's say if we had these three polynomial functions and you had to find the degree and leading coefficients of the following polynomials. Now the first one is f of x equals to negative 4x cubed plus 2x squared minus 9x plus 7. Now that one's nice because it's all multiplied out. It's all written in descending order as well, so that the degree of the polynomial for this case, for the first one, would be 3. So the degree we would say is 3 because that's the highest degree of any of the terms in the polynomial function. And for this term here, the negative 4x cubed, the coefficient of that is negative 4. So that's the leading coefficient. So it's negative 4 for that one. Now, but what if it's factored? Do we have to multiply it all out to be able to figure out what are the degrees and leading coefficients of the polynomial function? And it turns out no. What we gotta just do is figure out, okay, let's say, like, what if we multiply. Well, first, let me read out the function. If we have the function f of x is the quantity 2x minus 3 times x plus 4 times 3x minus 5, what if we had multiplied the first two factors together? Now, the one that would have the highest degree from the product of those two would be if we multiply the 2x times x, so that would be 2x squared. And then what if we multiply that polynomial times this 3x minus 5? Then the term with the highest degree would be what we'd get when we multiply the 2x squared times the 3x. So that would be what, 6x cubed. That would be the term with the highest degree. So in this case, the degree of the entire polynomial, when we multiply it all out, the degree would be 3. And the leading coefficient would be 6. Now similarly, what if we had the polynomial function f of x equals to negative 2x times x plus 3, that quantity squared, times x minus 4, that quantity cubed? Well, first, if you were to multiply out this x plus 3 times x plus 3, so when you square it, the term with the highest degree would be that x squared, right? And if we multiply that x minus 4 times x minus 4 times x minus 4, then the term with the highest degree from that would be x cubed. And then the one that, when we multiply this all out, so if we multiply the negative 2x times this x squared polynomial term, our factor in the middle, the one with the highest power would be negative 2x times x squared, so that would be negative 2x cubed. And then we'd multiply that times that x cubed, so we'd have negative 2x to the 6th. So that would be our leading term for the polynomial function if we were to multiply it all out, so that the degree of the polynomial would be 6, and our leading coefficient in that case will be negative 2. Now, what you're going to see when you discuss the graphs of these polynomial functions, that you're going to be able to tell a lot, and it's really a lot. It's really amazing how much you could tell just by looking at the term and with the leading coefficient and seeing, okay, or sorry, the leading term, and knowing, okay, what is the degree? And then one of the things that we'll need to know is, okay, is it an even or odd degree? So is it, like in that case, if the degree was 6, so it's even. If the degree was 3, that's odd. And then by knowing about the leading coefficient, and one of the main things will be, okay, is it positive or negative? What we're going to be able to tell is, like I said, really a lot from just that, but those two things will be able to tell, like, what happens to the far right of the graph. So, like, as you go off to infinity, what's happening to the graph that way, and also what happens to the graph on the far left side as it goes to negative infinity. So it's very important to be able to find the degree and leading coefficients of the polynomial functions.